Hello everyone. Today we're going to discuss about concentrations of solutions. In the last video lecture we were discussing about what is how do we measure concentration. Today we're going to see the qualitative measurement of concentrations, concentration in diluted solutions. That will be one subtopic. The other subtopic I would like to discuss in this video is how do we relate aqueous reaction and solutions in stoichiometry. So these are the two subtopics we're going to discuss. Before that, I would like to remind you about one way of measuring concentration, that was molarity. For those of you who will easily can, if you like to easily remember the formula for molarity, as you know, molarity is the number of moles of a solute divided by volume of a solution. And we always use an abbreviation for the number of moles. The common abbreviation is N for the number of moles, V stands for the volume of solution, and molarity stands with M. Now I'm going to draw a triangle here. This triangle would be the best way to remember the formula. I'm going to start with N here and M here, V here. What this means that if you like to calculate the number of moles, you just multiply M and V. If you like to calculate molarity, molarity is N over V. Or if you look for V, if you cover V, which is volume can be N over M. So this triangle would be the best way to remember the formula for molarity. At least one value would be given. In other words, M equals to N over V. This implies that N equals to M times V, or V equals to N over M. So this triangle would be the best way for you to remember the formulas. Having said this, I'm going to discuss about how do we prepare a diluted solution from concentrated solution. So diluted, what's a diluted means? Diluted means if you add more water or more solvent, I would say more solvent, into a concentrated solution, so it becomes diluted. Now the question that would be asked here, how much solvent are we going to add? How much solvent are we going to add here? So one of the relationship is that when the solvent is added to a dilute solution, the number of moles of a solute in a concentrated solution and in a diluted solutions remains the same. In other words, I'm going to use NC equals to ND, where NC refers to the number of moles of concentrated solution, and ND stands for the number of moles of a diluted solution. This is going to be our beginning point here. So like I say, NC equals to ND. NC can be calculated as MCVC equals to MDVD. Remember that N is always M times V. So when I say MC stands for molarity of concentrated solution, and MVC stands for volume of concentrated solution. MD stands for molarity of the diluted solution. Molarity of diluted solution. And finally, VD stands for volume of diluted solution. So the concept here is that the number of moles of a concentrated solution and the number of moles of a diluted solutions will remain constant. So that will lead us to this formula MCVC equals to MDVD. So having this formula, we can able to calculate some examples. So I'm going to give you one example here. Say for instance that how many milliliter of a 6.5 molarity of sulfuric acid are needed to make 375 milliliter of 1.5 molarity of sulfuric acid. Okay, now question mark. Now whenever you see a problem like this, you can automatically visualize that this is a relationship with diluted versus concentrated solution. Now the question in this case is, what is our MC? What is our MD? Okay, always higher concentration is going to be our MC. So in this case, our MC, which is concentrated solution, has 6.5 molarity. The diluted solution has 1.5 molarity. So the question, if you can break down this question, that we have a 6.5 molarity of sulfuric acid. This is 6.5 molarity of sulfuric acid, and we would like to dilute it to make it 1.5 molarity of sulfuric acid, to make it down, to make the concentration down. So the question is, how much water are we going to be add? That's the question. How much water are we going to add to reduce the concentration from 6.5 into 1.5? So again, we have 6.5 molarity of sulfuric acid. We would like to bring it down into 1.5 molarity of sulfuric acid, and the volume would be 375 milliliter. So in order to do that, that's a solution. In order to do that, we're going to use the formula MCVC equals to MDVD. So we are looking for, what's that we are looking for? We are looking for the volume of the concentrated solution. We don't have that, so I'm going to put X here. So the MC would be 6.5 M times X. The molarity of the diluted solution would be 1.5 M. The volume of the diluted solution will have 375 milliliter. So X can be 1.5 M times 375 milliliter over 6.5. So if you multiply 1.5 by 375, what do we get? We get 562.5 milliliter, and we're going to divide that by 6.5. 562.5 divided by 6.5, that would give us 86.5 milliliter. So 86.5 milliliter is the volume of the concentrated solution. Now someone might ask you the question in a different way. So how much water are we going to add? Are we going to add to make the solution to 375 milliliter? So the amount of water that you're going to add, make sure that it's going to be distilled water. We're going to subtract 86.5 from 375, so 375 milliliter minus 86.5 milliliter. that would give us 288.5 milliliter of distilled water. So this is the amount of water that we need to add to bring down the 6.5 molarity of sulfuric acid into 1.5 molarity of sulfuric acid. So that's how we can able to identify the a diluted solution from a concentrated solution. So our next topic is going to be aqueous reactions. Aqueous reactions and solution in stoichiometry. Solution in stoichiometry. So what we see here is that we're going to integrate the idea of stoichiometry with the solution problems. So this kind of problem would be an integration of chemical equation with a balanced chemical equation with a solution. So I'm going to give you a practical example. So the question that I would have for you here is, I'll write down the question: how many grams of calcium hydroxide are needed to neutralize 75 milliliter of 0.3 molarity of nitric acid. Okay, so you are asked to calculate the amount in terms of grams, and we are given volume and we are given concentration. So from these values we are going to calculate the amount of grams of calcium hydroxide which is needed to neutralize 75 milliliter of 0.3 molarity of nitric acid. So the very first thing that we need to do is we have to write our given values. What are the given values here? What do we know about the quantitative value? We have volume of nitric acid, which is 75 milliliter, and 75 milliliter is equivalent to 0.075 liter. When you want to change into liter, remember that you can divide by 1000. That's how you get your liter. We also have the concentration of nitric acid, so the molarity of nitric acid is given, which is 0.3 molarity. So the required value, what is that we are needed? The required value is the mass of calcium hydroxide. We don't know calcium hydroxide, how much calcium hydroxide we need here. Good. Okay, so once we have that, we need to write the equation between calcium hydroxide and nitric acid. So you can see that this equation is the neutralization equation, because we have alkaline solution here, or a basic solution, and we have acidic solution here. So the alkaline solution and the acidic solution, when they react, you get salt and water. So the salt that we get here is going to be calcium nitrate, which is aqueous, and water. And remember, when you do any type of equation, the equation always needs to be balanced. So when you want to balance the equation, remember that it's a good practice to begin with the polyatomic ion. So for example, we have a nitrate ion here. We have 2 nitrates on the product side, and we have 1 nitrate on the reactant side. So I'm going to put 2 here so that I can balance the nitrate here, and now I can balance the rest. So basically I have 4 hydrogen here, I have 2 hydrogen here, so I'm going to put 2 here, the coefficient 2. So I would have 2 oxygen, I would have 2 oxygen here, so the equation looks like balanced. Now let's go back to the problem. So according to this problem, we can see that when we see the stoichiometric relationship, 1 mole of calcium hydroxide is needed to neutralize 2 moles of nitric acid. Okay, 1 mole of calcium hydroxide is needed 2 moles of nitric acid. So, since 1 mole of calcium hydroxide needed 2 moles of nitric acid from the balanced equation, how many moles of nitric acid of 75 milliliter and 0.3 moles of nitric acid is going to be needed to react with calcium hydroxide? Now, this is indirect problem here. We don't have the number of moles. We're actually looking for the number of moles of nitric acid here, but we are not given what we have. What we have given is the volume of nitric acid is given, which is 75 milliliter, or like I said, it was 0.075 liter, and the molarity of nitric acid, so that was 0.3 molarity of nitric acid. So the number of moles of nitric acid, would be what? Molarity of nitric acid times volume of nitric acid, which means 0.3 m times 0.075 liter. So the number of moles is going to be 0.23 moles. So now we make a comparison here. 1 mole of calcium hydroxide require 2 moles of nitric acid. So let's say that if you have 0.23 moles of nitric acid, how many moles of calcium hydroxide you need? So you can do a crisscross here, which is 0.23 moles of nitric acid times 1 mole of calcium hydroxide over 2 moles of nitric acid. So moles of nitric acid will be cancelled by moles of nitric acid, and 0.23 times 1 divided by 2, 0.23 times 1 divided by 2, that gives you 0.012 moles of calcium hydroxide. Now remember, the question was, we wanted to know the mass of calcium hydroxide. So we have moles of calcium hydroxide. So 0.012 moles of calcium hydroxide has to be changed into mass. How do we do that? We have to multiply by the molar mass of calcium hydroxide. What is the molar mass of calcium hydroxide? That's going to be some weight of calcium, which is 40. Weight of oxygen in this case would be 32. Hydrogen would be 2. So that's going to be, I believe, 74. No, that's going to be 40 plus 32 plus 2. 40 plus 34. Yes, that's going to be 74 grams. So we're going to multiply 0.012 moles of calcium hydroxide by 74 grams over 1 mole of calcium hydroxide. So if you multiply 0.012 by 74, what do we get? You get actually 0. Let's do the math together. 0.012 times 74. That would give you that would give you about 0.888 grams of calcium hydroxide. So the idea here is that if you have a 0.3 molars of nitric acid and 75 milliliter of nitric acid, how many grams of calcium hydroxide you need. You need 0.88 grams of calcium hydroxide to do your neutralization reaction. Remember, neutralization reaction is a reaction between acid and base, and the product is always salt and water. This is the end of the topic for this video. If you have any comment, you can leave the comment underneath the video. Please make sure you like the video and like us as well, and share the video. And if you have any questions, any comment or any suggestions, please leave your message. Thank you very much, and I'll see you in another topic of chemistry. Thank you, and have a great afternoon or a great evening wherever you are. Thank you.